Welcome back, Rock Ridge. This is our new lesson for today. We talked in the warm-up about factoring and solving. Now we're going to use a technique called completing the square to solve some equations. So let's set the stage for what completing the square means. So we use this method when we have a perfect square trinomial, perfect square trinomial that you can isolate. So let's see what we mean by that. X plus 3 squared, the square of this binomial. Well, that's the same thing as x plus 3 times x plus 3. If you FOILed this out, first times first, outer times outer, inner times inner, last times last, you would get this perfect square trinomial. So when we see this, we could replace it with this. This was one of the factoring tricks that we could have memorized. If you saw that this was something squared and this was something squared and this was double that, you could quickly jump to this as your factored form. So we're going to make use of this fact today to make solving these equations easier. So let's walk this through a couple more times. X minus 4 times x minus 4, if you were to FOIL that out, you would get x squared minus 8x plus 16. Hopefully these are coming very quickly to you. Similarly, if we had x plus 6 times x plus 6, that would net out x squared plus 12x plus 36. Okay. Now, the real trick, going backwards to make one of these. This is what we're after today, is going backwards to back into one of these. So let's look at what we have here. Something perfectly squared, and a negative sign of that doubled. So this, you need to be able to see that this can be written as x minus 10 squared. Okay, that is the whole trick to today for solving with completing the square. Similarly, if you saw this, you should see this, and notice that 225 is 15 squared. Again, always have those ready in your mind. And so you should be able to see that that is x plus 15 squared. All right? So let's see what the steps for completing the square are. Let's write them down. I know they won't necessarily make a whole lot of sense as we're writing them, but let's get a complete set of notes that we can refer back to as we're doing these examples. So step number 1 for completing the square. Move the quote-unquote C term, or the third number, to the right of the equal sign. To the right of the equal sign. Okay. And again, we'll go through several examples where we walk through these steps to make it make more sense. Step 2, add 1/2 of b squared to both sides. All right, that's step 2. Step 3, factor the left side. Factor left side. And that factoring will basically be turning something that looks like this into something that looks like this. That's what we mean by that. Go from here to here. Step 4, take the square root of both sides. It'll be nice and easy to do. Take the square root of both sides. And then finally, step 5, solve for x. And it'll be pretty straightforward from there. Solve for x. So have these 5 steps handy as we go through the next 4 examples. So example number 1, we are told to use completing the square as our solution method. Remember, in this entire unit, you should never have decimal answers for x. You should never tell me that x equals 2.555 or whatever that is, okay? We need to, if there's a radical in there, we need to leave that in our answer, and we'll see that happen here. Especially when we come upon something like this, is it factorable? Is there something that multiplies to 2 and adds to -4? There's not, right? So completing the square is a perfectly fine method for doing this problem. Step number 1 is move c to the right side of the equal sign. This is your c term, the constant. The constant is your c term. So step number 1 is to move that term to the right of the equal sign. We do that by making it negative. leave a hole here. Step number 2 is to add 1/2 of b squared to both sides. If this is c, this is b. -4 is b. What's half of -4? That's -2. What's -2 squared? That's +4. So add 1/2 of b squared to both sides. Now, factor the left side. Factoring the left side should be much like what we did up here, going from this to this, because we have engineered a perfect square trinomial for ourselves. Steps 1 and 2, we have engineered a perfect square trinomial over here, so that we can easily write this as x minus 2 squared. We made that happen for ourselves on the left. The result of that on the right is a -2 plus 4, which is a 2. The next step is to take the square root of both sides. In this case, it leaves an x minus 2 on the left. On the right, we have a positive and negative square root of 2. The last step is to solve for x. To solve this one for x, we add 2 to both sides. So x equals the positive and negative, let's do the 2 first. Let's write x equals 2 plus and minus the square root of 2. These are the two solutions to this quadratic equation. And we use completing the square because factoring really wasn't an option. Those are the two solutions. Let's use completing the square to do the rest of these. These are actually all factorable solutions, but let's practice our skills of completing the square so that when we have to use it, we can. So let's go through step 1, which is moving c to the right of the equal sign. X squared plus 6x equals positive 16. Always leave a hole. Now let's engineer our perfect square trinomial on the left. Half of b, which is 3, squared, 9. Whatever you do to the left, you must do to the right. Usually people forget to put their red 9 over here. Don't forget that. Whatever you engineer for yourself over here, you have to balance it out over here. Now we've engineered x plus 3 squared for ourselves on the left. And we ended up with 25 on the right. Now we take the square root of both sides, and we end up with x plus 3 equals positive and negative 5. We can actually do the math on these. We don't end up with a messy little radical expression here. We end up with x equals -3 plus 5, and x equals -3 minus 5. So the two solutions to question number 2 are 2 and -8. Both of those are the things that you can put in for x that will make this a true expression. When you have nice pretty numbers like this, it's an indicator that you could have easily factored. Not easily maybe, but you could have factored this. This was a factorable expression. Something that looks like this indicates that you couldn't have factored it. Either method is fine for this particular problem. We are, of course, practicing completing the square, so we're forcing you to use completing the square on this problem. Let's do it a couple more times. This is an interesting special case if you were to do completing the square for this one. So let's first do our first step of moving c over. So we have 2x squared plus 4x, leave a blank, equals 16. Completing the square, notice completing the square works when you have only an invisible 1 in front of your original, right? Completing the square, perfect square trinomial, works when you have a 1 in front of there. That makes it easier, right? If there was a 9 in front of here, something else that was squared, you could also do the perfect square trinomial. But for the most part, we like working simply with 1. So when we come across this problem here, number 3, that doesn't have a 1 here, it behooves us to take that 2 out and make it a 1 to make things easier on ourselves. It helps us out. So let's factor out a 2 and make the work a little bit easier on ourselves. Now, what's half of 2 squared? Half of 2 is 1. 1 squared is 1. So we're going to add 1 to complete this and engineer our perfect square trinomial here. However, if you add 1 inside this parentheses, what you're really doing on this left side is adding 2 times 1. Because you're adding 2 times 1 on the left, you have to balance out the right with adding plus 2. So it's a little bit of a tricky one when you have something that looks like this for completing the square. Alright, let's bring this to fruition. X squared plus 2x plus 1 can be rewritten as x plus 1 squared. Our perfect square trinomial that we engineered can be factored like that, which is what we were after. Divide both sides by 2. And then take the square root of both sides. So x plus 1 equals the positive and negative 3. Or x plus 1 equals 3, and x plus 1 equals negative 3. X equals 2, x equals negative 4. Those are the two solutions to this original. And seeing this, we know we could have factored this. We could have factored this to x minus 2 and x plus 4. Number 4, a little simpler version of completing the square, so let's do this one more. Step 1, move the c term to the right of the equals. Step 2, take half of b and square it. Half of b is negative 1. Negative 1 squared is positive 1. Do not forget to put positive 1 on both sides. Alright, we've engineered a perfect square trinomial over here that can be rewritten as x minus 1 squared. This becomes 9. Take the square root of both sides. X minus 1 equals positive and negative 3. X minus 1 equals 3. X minus 1 equals negative 3. So x equals 4, and x equals negative 2. So positive 4 and negative 2 are the two solutions to this quadratic. Alright, let's mix this up. We're going to have different practice problems to solve. Everything is going to need to end up with an x equals something. Okay, we're not ever stopping at the factoring stage. Alright, so let's follow through here. We have our choice of methods for a lot of these. We are going to force you to use completing the square here, but we have our choice of methods for a lot of these. So solving this one. Number 5 is already factored for us. So this is actually very simple. We set each factor equal to 0. They were nice enough to hand us the factors, so let's continue with our work. Set each factor equal to 0 and solve. So that's a pretty quick one. The solution to number 5 is negative 3 and positive 3. If you have a multiple choice test or quiz, you need to have both negative 6 and 3 in your final answer, not just one of them. Number 6, I think the best approach to this one is what? When we look at this, what do we think? What's our gut tell us to do on this? Well, I see a greatest common factor, and I was told let's take that out first. So let's go with our gut and take 3x out. What do we leave behind? X minus 4. What do we think we do here? I'm expecting 2 solutions to this. I have a power of 2, so I'm expecting 2 solutions to this. So what do I do here to solve this? Perhaps setting x minus 4 equal to 0 is very, very obvious to most of us. But maybe less obvious is also setting 3x equal to 0. Both of these are factors. Both of them need to be set equal to 0 to find the solutions. This one's a very quick and easy one. X equals positive 4. How do we solve the left one? Divide both sides by 3. What's 0 divided by 3? 0 divided by 3 is 0. So we have 2 solutions as we expected. One of them is 0 and one of them is 4. You need both to have a complete answer. Number 7, again, much like number 5, they've already done all the factoring work for us. So let's go ahead and follow through with setting each of these factors equal to 0. If you would like, you can certainly include this factored out GCF of 2 set that equal to 0 if you need that for completeness sake. Now we all know that 2 does not equal 0. There's no variable here to address. There was no x attached to the 2. So this is fine. You don't have to write this, but this is certainly true. 2 does not equal 0. So that's the first factor. Second factor, 5 minus x equals 0. Subtract 5 from both sides. Divide by -1. Next factor, 3x minus 4 equals 0. 3x equals 4. X equals 4/3. Last factor, x plus 2 equals 0. X equals -2. These are your 3 solutions for x. Number 8, we're being forced to use completing the square, mostly just for practice. So let's recall our completing the square steps. Subtract 5 from both sides. Move the c over to the right of the equal sign. What's half of 6 squared? Half of 6 squared, half of 6 is 3. 3 squared is 9. So add 9. Don't forget to add 9 to the other side. We've engineered a perfect square trinomial for ourselves, so we'll factor that as x plus 3 squared. And we'll rewrite the right-hand side as 4. Take the square root of both sides. X plus 3 equals both positive and -2. X plus 3 equals 2. X plus 3 equals -2. So x equals -1 and x equals -5. Those are the 2 solutions. As a side note, somebody asked me the other day, well, what if you had an odd number in the middle here? What if you had a 7x here? What would you do? How did you divide 7 by 2? That sounds terrible. Yeah, it kind of is terrible. I mean, we can certainly go forward with it, but I wouldn't recommend completing the square if you didn't have an even number here, if you didn't have something to divide by 2. It wouldn't be the method that I would choose. We will continue to teach you several methods for solving these quadratics. Completing the square isn't one that I would use. It isn't my preferred method if I was faced with an odd number. That's a simple answer to that. If it's an even number, it's fairly easy to use completing the square to solve. Number 9, let's set everything equal to 0 and see what happens. So that's 2x to the 4th minus 50x squared equals 0. What would we do next? Hopefully when you stared at this a little bit, you saw that you have a greatest common factor. So let's pull that greatest common factor out. 2, also an x squared. That's the greatest common factor. You would leave behind x squared minus 25. So let's continue to stare at this left-hand side. Can we factor this further? We actually can, if we notice that this is what? That's a difference of squares. So let's continue factoring this difference of squares. Something squared minus something squared. Hopefully remember that a squared minus b squared gets factored into a plus b and a minus b. You have to have that ready to go at all times. So this gets factored to x plus 5 and x minus 5. And we still had this 2x squared out here. Now, we set each factor equal to 0 and solve. So 2x squared equals 0. X squared equals 0. 0 divided by 2 is 0. And x equals, well, there is no positive and negative 0. So we just say x is 0. It's got a double root. It actually hits 0 twice. And we'll learn more about double roots in further units. Let's continue with our list of factors that we need to set equal to 0. X plus, oh, I needed a different color. Here we go. X plus 5 set equal to 0. X is -5. X minus 5 set equal to 0. X is 5. So these are the 4 answers. Technically you have 0 twice. Those are my 4 answers to this power of 4 equation. Number 10, let's go ahead and get a 0 on the right and see what we have to work with. 2x squared minus 7x minus 9 equals 0. Let's look at this. We're not being forced to use completing the square. It might be a good option, but let's see what we have here. Is this factorable? We don't have a 1 here. We have some other number. So if we were to factor this, we would need to be looking for factors of negative 18 whose sum is negative 7. Could we find things that meet this criteria? There are 2 numbers that solve this. If you're unable to get there, we could certainly look into completing the square. But hopefully you easily saw that negative 9 and 2 solve this. Now, if you're using foci, you need to make a t-chart with a 2 on top. And like I said, 9 times 2 is 18, and we need to make the 9 a negative. You add negative 9 and 2, you get negative 7. If you're sliding and dividing, that's fine. You can certainly do that as well. We'll get to the same place in the end. Reduce this. Rewrite your factors. 2x minus 9 and x plus 1. Set each factor equal to 0 and solve. Set the other factor equal to 0 and solve. And these are your 2 solutions to this original equation, number 10. Number 11, again, I highly encourage everybody to move everything to the left and get a 0 on the right so you see what you're dealing with. So let's move everything to the left. To get everything on the left, we add 3t squared and subtract 6t. Add 3t squared and subtract 6t. If you need to do this in 2 steps instead of 1, that's fine. 3t squared and negative t squared, that ends up with just a 1t squared. Negative 7t plus 12 equals 0. We're faced with a quadratic here. We don't have an even in the middle, so I'm not advising to go with completing the square. Can we find numbers that multiply to 12 and add to negative 7? We'll think about it. Yeah, we absolutely can, right? T minus 3 and t minus 4 will get us to a positive 12 multiplying and a negative 7 adding. Easy peasy. T minus 3 equals 0, so t equals, not 0, 3. T minus 4 equals 0, so t equals 4. Those are your 2 solutions to this quadratic. Wasn't real clear when we first came upon this, but when we set everything equal to 0, factored and solved, we were good to go. Alright, we have a little bit of a typo on number 12. This should read x squared minus 20x equals negative 100. So once we have that fixed, let's shove everybody on the left and look at what we have. Gosh, this looks awful familiar. This looks like a perfect square trinomial. I've got something squared here, and double those 2 things here. So we've got a perfect square trinomial. Now, this is a trinomial. You could do find factors of 100 that multiply to negative, or that add to negative 20, and that's certainly fine. But noticing that this is a perfect square trinomial makes factoring and solving this so much faster. Seeing that this can be factored as x minus 10 squared makes this go very quickly. Now, what are the solutions to this? If we write this out, perhaps it'll be easy to see the double root scenario by doing this. If we set each of these x minus 10s equal to 0, you have x equals 10 and x equals 10, or x equals 10 double root. That's what we mean by double root. It happens twice. Those are the 2. Both solutions to this are 10. Okay? All right, go ahead and attempt your exit ticket, and then we'll work on independent practice.